Right, grade 12s. I'm going to start working you through the alcohols now, very quickly, and then see how we go. So this is the notes on the alcohols here. It talks to you about the structure of them. You can see here it mentions three things. Oopsie, I don't want to do that. It mentions three things here. The different types of alcohols. So this thing might draw for me when I'm in that mode. Anyway, so you've got primary, secondary and tertiary. I'm going to jump through to the PowerPoint and go through these because it works a little bit clearer, and then we'll come back and see, make sure we haven't missed anything. Alright, so here's the PowerPoint. I'll go through it as a show. So alcohols, they have got a general formula, and the general formula it's CnH2n plus 1. Works for any of the alcohols. You can try them if you want. The OH group we call a hydroxyl group, so that's here, and then the this hydroxyl group is the OH. The simplest one would obviously be where n is equal to 1. So if n is 1, then n plus 1 would be 2 times 1 is 2, plus 1 is 3. So there you've got your 3 hydrogens, and then obviously you've got an OH that goes with it. And that's methanol. Now if you're going to go up to your next ones, the next one's obviously got 2 carbons, so that's ethanol. And there's no other possibilities. If you put that OH on this carbon, it's still going to be the same molecule, just flipped around. However, when you move now to 3 carbons, the molecule's got different possible structures. So I've put both of them here. Here's one. That's propan-1-ol, because the OH is obviously on the first carbon. Now this one we'd call propan-2-ol. Obviously there's propan-1-ol. We'd call propan-2-ol because now the OH is on the second carbon. Now obviously there's no other possibilities. If you move that OH from there to this carbon, it's just this molecule flipped around 180 degrees. Now we introduced this thing of different classes of alcohols. So we call this one a primary, and we call this one a secondary. And let me explain why. In a primary, the carbon that is attached to the OH is only attached to one other carbon. In a secondary, the carbon that the OH is attached to 2 carbons. Okay? And because there's 2 carbons there, we call that secondary. Obviously, you can have others as well. We'll see them when we look at this next example. So this is the 2 different isomers of propanol, propan-1-ol, propan-2-ol. This little task for you. Stop the video and go and have a go at this task. C4H9OH has got 4 isomers. There's the normal straight chain propanol, butanol, butan-1-ol, but there's 3 others. Now go and have a look at them. Stop the video, please. Piece of paper, sketch them quickly, and try and name them as well. And then obviously come back here and see if you're getting them right. Think about the class of the alcohol as well. Try and see if you can assign them a class, first degree or secondary. Primary or secondary. Alright, so stop the video now, go and have a look at that. For those of you who've done that already, okay, so you're back with us now. Restart, we want to go and have a look at the answers. So here we go. Butan-1-ol, the OH is attached to a carbon, and that carbon's only attached to 1 carbon, so that's a primary. Butan-2-ol, again, the same as propan-2-ol, the carbon attached to the OH is attached to 2 carbons. So that's a secondary. Now you've got 2 other possibilities. If you move this one here, obviously it's just the same compound flipped around. And if you move it there, it's the same compound as this. So the only other thing you can do is take one of these carbons from here and move it around onto the middle. So now you get a methyl propanol. And if the OH is on the first carbon, then it's a 2-methyl propan-1-ol. Now, strictly speaking, you don't have to put that 2 because there can't be any other methyl propanols. If you move the methyl there, you're back to this one. That's methyl propan-1-ol, 2-methyl propan-1-ol, and here's 2-methyl propan-2-ol because this OH could go here. So there's a different type of isomerism being demonstrated on this page. Remember we spoke about types of structural isomerism. They're all structural isomers because they've got different structures. But these 2, the difference in the structures is a difference, if you like, to the difference here. Anybody remember what those would be? Okay, these two would be chain isomers because there's a different carbon chain, right? The carbon chain is actually changed, but the OH hasn't moved position. There's your hint for the second one. Those two are position isomers because the only difference is the position of the functional group has changed. The carbon chain is still exactly the same. And so these two would also be position isomers. Alright, so that's isomerism with the alcohols, and those would be chain isomers because different chain structure. Need to have a quick look at the manufacture of these. I'll just run through quickly. So you can make alcohols by fermenting sugar, natural sugars, glucose. If you put some yeast in there, keep it fairly mild, warmish temperatures, the following reaction will take place. The sugars will be converted by the yeast into ethanol and carbon dioxide, and that's how all drink, well, most, I think, or possibly all alcohols that you drink, that's how they're made. So beer, wine, all those things are made like this. That's how the alcohol is produced by fermentation of the yeast. Now, there's another way which we looked at in reactions of alkenes. You remember, you can add water on, you can hydrate them and add half of the water on anyway. Anybody remember the conditions for those off the top of your head? You need your acid catalyst and you need fairly high temperatures. So there are advantages and disadvantages to each of these. I'll run through them quick. So for fermentation, obviously using renewable sources, grapes or fruit or some form of something that you can grow. Low energy is only 25 degrees and very cheap process. Just throw them in a barrel and it happens. There are some disadvantages there. You have to do one batch at a time and then you throw that all out and get a new batch. So clean your containers, etc. So that makes it slow, it's time consuming, you've got to stand for a long time. And the product you get is impure. Now, in the case of wines and beers and things, you want the impurities because that gives it its taste. You get tannins and all sorts left over from the hops or the grapes. But if you're trying to make ethanol, then this is not a very good way to make it. If you want to make pure ethanol, it's better to use this method. And the reasons would be, this is going to be fast, it's done in industry, it gives you 100% pure product or very, very high purity product. And it's a high yield and it's a continuous process. You can let this run 24 hours a day. Obviously disadvantages, you're going to need high temperatures, as we mentioned, and it's non-renewable and it's expensive. You need phosphoric acid catalysts, you need to get your ethene. Why is it non-renewable? Well, where do we get ethene from? That's going to come from the fractional distillation of crude oil. You might get some out there, or you might get it from cracking the alkanes. And all of those come from crude oil. That's all expensive. You've got to get the oil from out of the ground. Very expensive processes. All need high temperatures, etc. So although some advantages, some disadvantages. Okay, now let's jump through to the reactions. All of that is in the notes, by the way. We'll just jump across there maybe quickly, see where it is in the notes, make sure we haven't missed anything. So functional group is there. Oh yes, triol, if they've got more than one OH, then it's going to be a diol or a triol. Propane 1, 2, 3, triol, glycerol, you might want to try and draw the structure of that. You're going to have 3 carbons, you're going to have an OH on each one. Okay. Then we mentioned the primary, secondary, tertiary. It's written down in words there for you. You should be able to draw the structure of all of these. 2-methyl, 2-butanol. Have a go drawing these. You can check them in the completed section of notes that I've put up. And then preparation. A couple of notes mentioned there about preparation. But now let's move on to the reactions of the alkenes. Actually, I think I'm going to stop the video there. Of the alcohols. I'll stop the video there and I'll make another one. It's better to make shorter videos, I think, than making long ones. So